There we go. Hi, everyone. I'm Catherine, and I'm excited to introduce today's workshop lead. Achala is amazing. She's a master's student at UC Davis studying biological systems engineering. She's been my TA, and she's awesome. She's co-founded the biomanufacturing company Fixed, so you should definitely check her out. She's one of those people that's going places. And we are lucky enough, she is one of the TAs from Engineering 3, which is an Arduino-based class at UC Davis. So she has very kindly offered to give us an introduction to Arduinos, and especially to Tinkercad, which is an online software that will make it easier for you to interact with your teams. Achala?
All right, yeah, hi folks. Very excited to be here with you all today. My name is Achala. Like Catherine said, I'm a master's student here and I've worked with Arduino. So we'll go through a basic overview of what Arduinos are and then the Tinkercad platform, which will allow you to virtually design, build, and test your circuits cheaply and effectively and safely in a COVID world.
So Achala, I'm going to go ahead and stop share screen on my end, and then you can go ahead and share screen from your end.
Okay, sounds great.
Tara, could you pin Achala's video?
Yes, I can do that. Okay.
All right. Sounds good. Welcome to our workshop. If at any point, if you think I'm going too fast, if something doesn't make sense, feel free to mute yourself and ask me. It's hard to monitor the chat when I'm speaking. So definitely unmute yourself, no problems there. Or if you don't understand anything, happy to add clarifying information. So here's what the rest of the next hour or so is going to look like. We're going to talk about physical computing, and then we're going to talk about Arduinos. What are the basic components? How do you operate them? And then we're going to talk a little bit about breadboards, talk about tools that improve rapid prototyping and give you sort of easy access to developing new circuits. And then we're going to talk about Tinkercad. We're going to help you set up your account, and then we're going to walk through an example circuit that we can build together on Tinkercad. It's fairly simple. We've got an input and then a couple of outputs. It should be a good basic to take and improve upon. So physical computing. Physical computing is basically interactive physical systems using software and hardware. So if you look at this picture on the right-hand side of the screen, there's a terrarium that's being controlled by the Arduino, and there's a fan built in, a temperature sensor. And so this is an example of a physical system, right? We're gathering real-world information with temperature and humidity and light sensors, and we're telling that to our interactive system, aka computer or a microcontroller, and we're using actuators, things like valves and levers, to control for action. So this together comprises physical computing. So the first thing we're going to talk about is digital versus analog. There's different types of sensors that we can use. Digital sensors often just have two states, like on or off, high or low. You can think about it like, turning on and off your light switch, right? You've got an on state and you've got an off state. It's binary. So in terms of computer, it's either a 0 or a 1. And there's a number of different types of digital sensors. Another example is like you could have a push button, right? A push button state has 0 if you're not pressing it, and then 1 if you are pressing it. But then there's also analog sensors, and these are continuous states like temperature and pressure. It's no longer just on or off. What if I want to measure temperature 29, 29.1, 29.2, right? So something that has a continuous flow is an analog signal, and for that we use analog sensors. Any questions here? Okay, if not, the Arduino is able to take both inputs, and we'll talk about how we can incorporate digital and analog inputs into the Arduino. So a quick recap for, everybody on circuits, right? The basic, things we want to know about are voltage, current, and resistance. So first, in any circuit, we're going to have a power source, generally a battery or your Arduino that's going to be powering it, and current flows from positive to negative. So in this analogy, right, we've got current flowing, it's going, against stream, it's going to the resistor, and then it's feeding current to the LED. And you'll see that each of these components, resistor, LED, the switch, have their own symbols. And as you're building your own circuits, you're likely going to want to build a circuit diagram, which is comprised of these symbols, just to keep things simple and easy to read for yourself. And of course, these wires here are just lines or wires connecting each of these components. So to dive more into this, right, we can think of, a circuit with the water analogy. Is there anybody who could tell me what charge is represented by here? It's on the screen, but could you give me more explanation why? Anyone? I trust your abilities. All right. Well, charge is represented by water, right? Water is flowing throughout the system, and it's really carrying throughout the entire system, and it's carrying the voltage. The current is represented by the flow of water. You've got your pump here, which is pushing water against the norm. That's what's doing the work. You can think of that as your source of energy. And then you've got your valve, right? It's controlling how fast the current is flowing. And so throughout this, you've got a voltage drop. You can think of it like that. And so you've got a system where water is being pushed up by your source, and then it flows from a positive charge to a negative charge, where there's less energy, positive to higher to lower energy states. And that's how circuits work themselves too. So you've got a battery flowing from you've got your switch, your current is flowing in this direction, it goes through the resistor and then back, and you always connect it to the ground. So in terms of talking about connecting your circuit, there's polarity to certain objects. For example, your LED. You can't just wire either lead of the LED to any side. There's a positive side and there's a negative side. Usually the anode or the positive side has a longer lead and the cathode has a shorter lead. And you need to wire them in their appropriate respective orientations, or else you risk burning out your LED. And with the LED, it's okay. But if you're wiring other things that have polarity incorrectly, like your push button or an op amp, you risk blowing them up and potentially creating a hazard for yourself. And so one of the nice things about Tinkercad, this circuit simulation software we're going to be using, is it'll tell you what the anode and the cathode is if you hover over it. So it's a really good prototyping tool to use, especially as you're starting to get familiar with some of these components. Okay, so what you see here, you should be pretty familiar with this, but this is an Arduino. It's a microcontroller. Basically, you can code, you can give it some code, basically a set of instructions, and connect that to electronics or circuitry, and it'll conduct any task that you tell it to. For example, you see this sunflower here. It's connected to a photoresistor. It detects ambient light and then turns the flower to face the direction with the most light facing it. So it's a way of rapid prototyping. And you may be thinking, well, this is just prototyping. Is it something I'm just going to use in academia? Not at all true. There's a number of companies built using microcontrollers like Arduino and add-ons like Raspberry Pis that are making very real solutions. And I tell you this because when my initiative or my company first started, we were working with Arduinos and Raspberry Pis. So you have the potential to take this much further than just a project, but I think this is a very good starting point for you guys. What are the basic components of an Arduino? First, you've got the USB port. Here is where you connect it to your laptop. You've got pins 2 to 13 here, and you'll see that they're labeled digital, so therefore digital inputs only. You can power things like your LED, your push buttons, even motors, DC motors, and we'll see some of these examples later today. And then you've got your onboard LED. It's actually connected to pin 13, and it's a way for you to check if your code is working. So say you have an output assigned, or you're wiring or powering something to pin 13. This onboard LED will blink to let you know that your code is working correctly or that power is being passed through pin 13. The next set of things you have are the analog inputs, and they're labeled A0 to A5, and they also have analog written explicitly on them. And this you can use for things like pressure sensors, temperature sensors, dials for controlling fan speed, so on and so forth. And then you've got your 3-volt power input and your 5-volt power input, followed by a set of ground pins that you're going to use when you're developing your circuits. And of course, you've got the VIN pin to plug in a battery or any other power source. Generally, we tend to just use the USB port that's connected to your laptops. Okay. So if you're using a physical Arduino, the first step that you're likely going to take is connecting your actual Arduino to your laptop. You're going to have to use a USB-A or a B cable, and this does 2 things. 1, it powers your Arduino, and 2, it provides a way for your Arduino to communicate with your computer, right? An Arduino is actually what is known as a slave, and it needs to be controlled by a master. And these are not terms that I've come up with. This is what they're called. So you need to connect it to something like a microcomputer, like an Raspberry Pi or your actual computer. And then you can use your computer to send code, and there you'll be able to say, turn this pin on, set this as an input, or turn this pin off. And I know that sounds a little abstract right now, but it'll make a lot more sense as we build. And some of you may even have Arduino experience already, so hopefully this is just a review. The second thing is you're going to need to download the IDE for this Arduino. For this, you're going to use your laptop. You're going to go to the Arduino website and then just download for whatever type of computer that you have, either Mac or Windows. It's free. It's going to ask you for a donation when you try to download it, but know that you're getting startup kits and it's already been paid for. No need to make that donation. Feel free to click no thanks and continue. And so just go ahead and download that. And then here's what it'll look like when you run it, right? Here's an example of some code. And when you're running it for the Arduino IDE, we refer to codes as sketches. And we're going to learn more of what this is today. So here's generally what the setup of the code looks like. You always have 2 blocks, right? First, you have the void setup. And here, this is where you declare your inputs and outputs. It's telling your microcontroller where to look and what to look for. I am declaring pin number 8 as an input. So please look for signals coming in. And then I'm declaring pin 10 as an output. So whatever relationship we've defined between the input and output will be sent to pin 10. And then for your void loop, right, you've already defined all of your, you're telling your computer where to look, and now you're telling your computer what you need to do with it, right? I'm looking there, what do I do now? You can say, hey, after 10 seconds, turn this LED off. After 10 seconds, turn it back on. These are all instructions. The what falls under the void loop. Again, I'm going to stop here really quick and see if any of you have any questions. Okay, if not,
Wait,
moving on.
I actually do, sorry. So
Go
this
for it.
isn't too related to this, but you've mentioned Raspberry Pis a couple times before, and I'm familiar as to what that is. You might give me a quick little.
Sure. Yeah, a Raspberry Pi is it's basically a microcomputer. It is a microcomputer, and it's much similar to what your computer can do, right? You put an LCD screen onto it and it's exactly like a computer. It's a very easy prototyping tool, much like your Arduino. It's also like 30 or 40 bucks, and it's often used for rapid prototyping, and it runs Linux on it. That's also a fantastic tool to use. You can run the Arduino IDE. So it's basically a replacement for your computer, and it's another small computer board that looks just like your Arduino.
Okay,
or similar to your Arduino.
Thank you so much.
Absolutely. Yeah, no, thank you for asking that. Okay, next one. So now that we know what the Arduino is, we're going to talk about some tools that you need for prototyping. So the first thing is, apart from the circuit parts that you're going to need to have a breadboard. And this is this device or this interesting looking board here. And fun fact, it was actually named after boards that were used for bread in early prototyping history. People were using literal breadboards as forms of, bases for their circuits, and the name has since continued. Please don't try to cut your bread on this board. It's not going to be efficient. But basically, how this works is you're able to connect parts of your circuit here and have an easier, more streamlined form of connecting the wires. And here's how that works. So each of these strips, or these holes that you see here that run horizontally, are connected by conductive strips, and each of these positive and negative strips are connected vertically through this conductive strip. And in the middle, we have a little ravine that divides the board, so these two aren't connected. So essentially, if you connect something, so if we go back here and we see this is connected, the entire row here is able to get power just because this wire is connected. So if you see here, this wire is connected to digital pin 3, and anytime you connect to a digital pin, it's basically giving power from the Arduino to your circuit. And you can tell how to control the power, right? Every 10 seconds, turn off power and then turn it back on, right? That causes the blinking of the circuits. And then you'll see here that this is connected to the ground, right? This is a resistor, and you'll remember that an LED has polarity, right? And you'll see that the cathode is connected to the ground and the anode is connected to the positive, right? And it can often get confusing, but you'll be able to distinguish that easier on Tinkercad. And the nice thing is, you've connected the positive and the negative wire to each of these rails on the breadboard. So you've got the ground that's connected to the negative on the breadboard, and the 5 volts that's connected to the positive on the breadboard. So now when you connect your resistor to this rail, you're actually connecting it to ground. And so now you have a complete circuit, power, LED, resistor connected back to ground. So you've completed the entire loop. So current is flowing from positive to negative. So I have a question for you guys. What happens, I mentioned that there is this divide where these conductive strips aren't connected. What happens if you now connect your LED on either side of this bridge here? Will current flow? How will you be able to power it?
Yes, current will bridge over the ravine there. And I would assume with an LED, you probably see that by it lighting up.
Actually, yeah, I mean, it depends on how you wire it up, right? So across this row here, current will not flow through. You have to have it connected separately to power and separately to ground. So for example, you could power it through here and connect it to ground here, and then the current will flow, correct? But just through these conductor strips, they won't flow. So your answer is right? In terms of building this LED circuit, as long as you power it separately, power each rail separately to power and the other side to ground, current will flow through the LED. Okay, so the next thing we're going to talk about.
Can I ask
Sure.
real quick, did you say both sides also need to be ground as well?
No, so you need to connect one side of the LED to ground and one side to power.
Gotcha. Okay, thank you.
Yeah. Ground and power being their respective anode and cathode counterparts. So yeah, but if you connect, you can't. So for example, if this LED was placed horizontally, so within these two holes, right, then you wouldn't be able to power it. But because we have it over the bridge, we're able to power this one to power and the other side to ground, and that would flow just fine. So the next sensor that we're going to talk about is the TMP36. It's basically a low voltage precision temperature sensor that measures in centigrade or Celsius. So the default values that are coming out of this are measured in Celsius. And if we as US folk want to convert to Fahrenheit, we need to have a conversion in our code. So there's a couple things to note about this. This is actually a curved sort of face on one side and a flat face on one side. And so when we're defining what power, output, and ground are, we want to always look at it from the flat side facing forward, so facing you. So basically the rightmost leg is connected to ground, the leftmost leg is connected to 5 volts, and the middle leg is what you connect to power. So whatever digital pin that you want, or whatever analog pin that you want to connect it to, will be connected to the middle one. And speaking of analog, this is an analog sensor because temperature is not digital, right? It's not high or low. It's 30 degrees Celsius, 31 degrees Celsius. You can measure continuously along the spectrum instead of it just having 2 states as on and off. And we're gonna be using this in our circuit a little bit later today.